Compared to other programming languages like JavaScript, Ruby, Go, and C#, developing applications in Java can seem slightly more complex and frustrating. On one hand, we cannot ignore Java's platform independence and automatic memory management. On the other, Java's syntax often requires you to write more lines of code as compared to other programming languages. Yet, Java is used profoundly in web development. But how? That's where frameworks and libraries come in, and one of them being Spring Boot. Spring Boot is a powerful Java framework built on top of Spring. It is designed to create Java-based applications with minimal configurations. This means that the complexities of Java are hidden away and you can focus solely on writing the logic for your application. Spring Boot has become so popular that it has been enlisted in the list of the top 10 developer skills which are on the rise. Additionally, it is also preferred by over 12% of web developers worldwide, according to a survey conducted by Statista. So, if you are interested in Java web development, learning Spring Boot can be highly beneficial and rewarding for your career. And that's exactly why we have curated this list of the top 30 most commonly asked Spring Boot interview questions and answers. This video is divided into 3 segments: basic, intermediate, and advanced, with 10 questions in each module. So without any further ado, let's get started.
So now moving on to the PPT part, we'll start with the first question, which is, what do you understand by now Spring Boot in general, if you talk about it, is like a bunch of, I've said this in before as well, that Spring Boot is a framework which hides away the difficulties of Java, because if you try doing web development with Java, it can be a bit more complicated as compared to other programming languages. So to make that configurations, or to simplify those configurations and basically make your life easier, we have Spring Boot, or in technical terms, Spring Boot is an open source Java-based framework that simplifies the development of Spring applications by eliminating boilerplate configurations. If you try to manually configure a Java-based web development application, it is going to take you a lot more work, and at some point it will get really frustrating because you have to manage every single minute detail by yourself, and humans are prone to errors, so there is a very high chance that you might make a couple of mistakes, and then at the end your whole application might not work. And then to save you from that frustration, we have Spring Boot. Additionally, it also offers embedded servers default configuration. Moving on to our next question, how does Spring Boot differ from the traditional Spring framework? If you must have worked with Java before, you will know that there is Spring Boot and there is Spring as well. Now let me tell you what the basic difference is with the help of an example. Say, if you have a traditional Spring application, it is like you're renting out a house and it's unfurnished. There's nothing. There's just one room. You're renting it out. Now you have to you have to bring everything, including the almirah, the bed, the tables, chairs, every single thing you have to bring on your own. All Spring provides you is a space or a platform to create your application. But with Spring Boot, it provides you the additional stuff as well, like the almirah, the bed, a couple of posters and plants. So you get a whole bunch of requirements along with the room itself, so that all you have to do is just go in there and start living, which as a user for you will be more convenient supposed to just renting out a empty room. Moving on to our next question, what are the main features of Spring Boot? Now the main features, although there are a lot of features of Spring Boot, the main features includes auto configuration. Now auto configuration is, say, if you add a starter for hosting your website on a web server, then Spring can automatically, when you add the dependency in your pom.xml file, which is a file you can find inside Spring Boot, if you add that particular dependency, that I want to add the starter web dependency, then Spring Boot automatically configures the server port and every other requirement that you might need to host a server. To host the server locally on your local web server. The next thing we have is Spring Boot starters. Now Spring Boot starters, again, it's like the way I told you about the Spring Boot starter web application. Similarly, you have a databases starter kit also. It's just basically a kit with a bunch of, like, if you're installing a database, there are certain libraries included inside the database application. If you must have worked with JDBC, you will know about this, because when you start setting up with JDBC, you actually get confused. Should I do Maven? Should I do Gradle? Should I do Ant? And then, like, there are a bunch of dependencies and half the versions will not even be working it will not be compatible with your current version. So to avoid all of this, we have Spring Boot starters. What Spring Boot starters does is it brings together all of these different components and picks out the default version, not the latest version. It's the default version. It brings them together and in one packet, puts it in a kit and hands it over to you. That is Spring Boot starters. Next, you have Spring Boot Actuator. Now, this is another very helpful tool. This helps you monitor the endpoint. Like you'll be hosting it on your server, right? There'll be a local host 8080 port will be there in which your website will be hosted. So you can check the health of that particular server of your hosted website by using Spring Boot Actuator. This is also another dependency. You don't have to configure anything. You just have to include the dependency in your code. That's it. And then if you put localhost 8080 slash, if you put the health, you will actually get the health of the website and you will get every single log and metrics of your website just by including one dependency. That's what I'm saying. Spring Boot makes your configurations very easy. And the last one that we have is a Spring Boot Initializer. Now, this is a website from where you can download the bundle, the starting bundle. You must know when you install React, it automatically, like you can just directly start it. But with Java, you have to like start from the basic from the scratch. But with Spring Boot Initializer, you can download the starter kit and directly host the website and directly host your code on the server. Moving on to our next question. What are Spring Boot starters? We just discussed about them, Spring Boot starters. Let's look at them in detail. So Spring Boot starters, you have a bunch of them. Spring Web is there, Spring Boot DevTools is there, Spring Data JPA, H2 database, MySQL or PostgreSQL, Spring Security. Now all of these come under different domains, such as Spring Web and Spring Boot DevTools come under the web application part. Spring Data H2 database and MySQL PostgreSQL under database. And then Spring Security is obviously under security. Now all of these starters you can find in the Spring Initializer's website. Let me show you. If you go into Spring Initializer, which is starts.spring.io, if you go to this website and all you have to type is web, see you can see starter web, and if you type JPA, that's the database. Security also, Spring Security, it's there, a highly customizable authentication and access control. Similarly, there are a bunch of other dependencies which you can use for your building your Java application. So now let's just look at one of these in detail, such as Spring Web. Now, what does Spring Web provide? It provides embedded web server. Embedded web server is like your Tomcat you must have worked with. That's the default one you get with Spring Boot anyways. So Tomcat is another local host server which can host your website. Then Spring MVC is there, Jackson is there, support for building RESTful APIs is there. To sum up, Spring Boot starters are pre-configured sets of dependencies designed to simplify the setup and configurations of commonly used technologies and functions. Additionally, these ensure compatibility and reduces the chance of missing critical dependencies. Again, it puts together every single library and dependency that you might need. It puts the default versions of all of these libraries so that no clashing key, oh, this version is not compatible, so that you will not encounter this particular error. That is why you have Spring Boot starters. Moving on to our next question. How do you create a Spring Boot application using Spring Initializer? Talking about all theory, now finally we have a hands-on part about how to create an application using Spring Initializer. Go into Spring Initializer and everything, let's just leave everything as default. And let's just add the dependency as Spring Web. Okay. And generate. Should be downloaded. There it is. Oh wait, I forgot to extract it. Okay, let's extract that first. And there we go. That's done. Now, open your Eclipse or any IDE that you have. Then import projects, existing Maven project, browse, and let's navigate to the one that we just downloaded, demo. And this particular folder is what we want. There'll be a POM file. Okay. Now there's your POM file in which you will have all of your dependencies. Okay. There is your dependencies, the starter web that we just included. Now there's a problem. If you try to directly launch this application, this is your main class. Let's try to run this. There is Tomcat setting up on port 8080. Okay, now let's try to access localhost 8080, and there is no application mapping for this particular route. How do we do that? Let's fix that first. So we need to create a new file, a new class. Let's just call it hello controller. So the problem that's happening here is whenever we're hosting this website, we haven't specified what to display to the user, and that is why we're getting this default white label error page, which will be common in every other Spring Boot application. So what you can do is configure that path. So let's do that, hello controller.
Now let's add a REST controller here. REST controller. And REST controller is basically your REST API. REST API is this controller, as in this page, this API is this controller. So what we're trying to do is get mapping for the default, the root. That's the /root. Let's have we need a function here. Let's call this home. Okay. Now return hello, welcome to this website. Okay, we need to import get mapping. We need to import REST controller as well. Okay, everything is good. Now let's try to run this. Terminate the current session, clear it. Now demo application, run as Java application. Okay. 8080, it should be working. And it's working. Hello, welcome to this website. Now that we've set the default landing page, we are getting this in return. Moving on to our next question. Moving on, now with this hands-on, I believe you have a clear understanding of how you can use Spring Initializer's website to download the initial starter bundle and then host your Java website. Moving on to our next question. What is the purpose at Spring Boot application annotation? Let's get to know this in detail. Now, this you will see, if we go back to this code, you will see @Spring Boot application. What is this used for? Let's look at it. Now we have 3 annotations other than Spring Boot annotation, which is configuration, enable auto configuration, and component scan. What are these? Configuration is the one that declares the class as a source of Spring configuration. So the configuration class, it's like a blueprint. If you declare, if you go into this particular, if you open Eclipse again, you can see it's a Spring Boot application. But instead, I can also define this as configuration here. Although it won't work because it will throw an error because this is not a configuration class. But wait, let me remove that. So the configuration class, it basically acts like a blueprint. It's like you have seen functions, right? Configuration is similar to functions. So once you declare any class as configuration, you can use that class as a default template for creating even more child classes of that same parent class. That's configuration. Next, you have enable auto configuration. This enables Spring's auto configuration, as in all the dependencies and everything that is included. It triggers, it asks Spring to look for all the dependencies that you have included in your file. Next, you have component scan. Component scan is that there will be different packages. There will be service, there will be components named as service, which we'll get to know in the later parts of this PPT. So there will be different components with different names, like your Spring Boot application was there, then your configuration was there, service is also there. So these are different annotations, which every single class will have different annotations. There's bean as well. So a root controller is also there. It was REST controller. So we used REST controller here as well. Get mapping is also there. Now, how does Spring Boot know you have to look out for these? That is what you're including into component scan. Now, if you put all of these 3 together in one particular place, you get Spring Boot application. So Spring Boot application is nothing but a convenience tool so that you don't have to use the boilerplate code. What I'm trying to say is, you could have run the same code, this one, with the help of all of these 3. As in, I could have added, instead of this, I could have just added configuration, component scan, what was the last one? Enable auto configuration. Enable auto. Now I'll have to import these three. Configuration, component scan, and enable auto configuration. I'll just comment that out as well. Now, if I terminate this, clear this, and run the code again, okay. So now if I go in there and reload it, it would still work. So what I'm trying to say is, if this Spring Boot application is just there as a convenience class so that you can avoid using, instead of putting these three in there, all you have to do is just put one single annotation here. So you don't even have to use these imports here, and you just need one import, one annotation, and you're all set to go. That's the only reason why we have Spring Boot application. So, or in technical terms, it is an effective meta annotation that combines these three important annotations and reduces the amount of boilerplate code that you might normally need. Moving on to our next question, what is the role of application.properties file in Spring Boot? Now we all know that how difficult it is, not in JavaScript, in Java, that if you have configured everything and then at the end you realize ki, oh, maybe I should have changed this particular property. I don't like the way, like I had to change the database's password, I had to change the server's port, and then it gets very hectic to try to locate wherever you have changed it. And if you have hard coded it, like if you have set up a variable for it, then it's fine, it won't be that difficult. But if you unfortunately have hard coded it, then you're just gone, because you have no idea wherever you have used it, and you have to change in every single, you have to go through like maybe 2-3 files and you have to find that particular port, you have to change it. It's very hectic. So that's exactly why we have application.properties file in Spring Boot. It will be right here in resources, application.properties. Here, what the biggest deal with this file is that it provides you a centralized place where if you have any change in your application, such as changing the database's name, password, changing the port, or any other change such as this, then all you have to do is navigate to the application.properties file and update that particular line there. And I'm saying line because you don't have to put a whole code there, just update one single line, as in spring.database is equals to the name, the new updated name, and the Spring Boot will automatically configure it, meaning you don't have to worry about changing or locating wherever the server was written by you. So it just basically again simplifies your life a lot. So, or in technical terms, it is a configuration file used in Spring Boot applications to define application-specific settings. The best part about this is that it allows you to change the behavior of the applications without altering the entire code or without altering the source code. Meaning you don't have to touch the main code, and all you have to do is just write that one line in application.properties. Spring Boot will take care of updating it every single elsewhere. Moving on to our next question. How can you run a Spring Boot application on a custom port? This is what I was talking about. Now I want to change my port. Right now this is hosted on 8080. I want to change it to say 8081. How do I change it? Now, instead of going through a lot of hard stuff, all I have to do is server.port is equals to 8081. And I'll save this. I'll have to terminate this. Clear it. Demo application. And it's starting on 8081. Obviously, now this won't work. 8081 will work. And if I reload this, yeah, because we have changed the default port. So now this is not the port anymore, we have our new port here. And that's how this application.properties makes our life so much more easier. Moving on to our next question, which is, what is Spring Boot DevTools? Now, you must have seen that every single time I'm applying some change, I have to manually terminate this, then manually clear it out as well, and then go into demo application again, and then start it all over again, like restart it. Every single time I'm making even the minute change, I have to stop the server, clear the terminal, then restart it all over again. So there is a dependency, there is a library that you can put in your Spring Boot application so that you don't have to go through that. Now, the reason why I didn't add it in the beginning is so that I can show you how difficult it is to not have live reload and how easier live reload makes your life. So what you have to do is go to Spring Initializer, add web we already had it. No, let's just download both of them. Spring Web we added. Other than that, we need Spring Dev tool, boot dev. Yeah. Okay. Now let's click on Explore, and there is your POM file. Oh God. Okay. Copy it, and not this. Okay, wait. The Spring Boot starter test is there. It should be here somewhere. Starter test is there. There it is. Copy the dependency. Yeah. And now that's ending. Okay. Paste it here. We need scope. We don't need optional stuff, but I don't care. Let's just put it there. Now, okay. Now if we try to run this file, alright, so the port has started again. Let's go check it. It's working. Now, let's try to change the port again. Let's just remove the whole line. Okay. Now you can see how it's reloading on its own. Like I didn't reload it. It just automatically started on 8080, which was the default server. So if I go in here and reload it, it should not work. And it's not working. So we go here, 8080, and it has automatically made the required changes. I opened Notepad in the middle. Okay. So in technical terms, Spring Boot DevTools, it's a development time tool that provides a set of features to improve the development process, such as automatic restart, live reloads, etc., like we just saw. Moving on to our next question, or our last question of the beginners module. What are embedded servers in Spring Boot and which servers are commonly used? Now, an embedded server in Spring Boot it refers to the integration of web server like Tomcat, Jetty, or Undertow, which is directly within the Spring Boot application. I'll show you this. It will be here somewhere in the POM file. I opened it. Yeah, there. If you look around a little, you should see, in this one, the Spring Boot starter web, Tomcat is automatically included. So if you have to include any other dependency, you have to write the code for excluding Tomcat, and you can put in any other server. So this default Tomcat server, you can see here, there. Tomcat started on port 8080. This is included inside your Spring Boot starter web framework. So that is an embedded server. So the Tomcat is a default one. If you want to change this to say Undertow or Jetty, you'll have to manually exclude Tomcat and include that one server instead. So moving on to our next question, what is a Spring Boot Actuator? Now, Spring Boot Actuator, in technical terms, is a sub-project of Spring Boot that provides production-ready features to monitor and manage your web applications. What does this mean? You must have seen a car's dashboard, right? So just by looking at the car's dashboard, you can figure out a variety of details about the car, such as the car's speed, the warning lights, the engine temperature, the fuel level, every single thing just by looking at the car's dashboard. This is similar to how Spring Boot's Actuator works as well. Spring Boot Actuator, instead of showing the car's dashboard, it shows you your website's dashboard. It shows you your website's health, logs, and other metrics, which if you do it manually, again, it takes a lot of effort, but Spring Boot Actuator actually simplifies the whole process. Now, the best part about this is that it exposes endpoints such as actuator/health, actuator/metrics. You have to just search for this endpoint within your local host. I'll show you how it's not a very difficult process. This provides information about the app's state, metrics, logs, environment, and much, much more. Let's see how this works so that you'll have a better idea about this. First, we need the dependency. So, Actuator, search for Actuator. You'll have it. Click on Explore. Here, Actuator should be here somewhere. Actuator, there it is. Copy that dependency. And, oh wait. No, not this. Actuator, yeah. Explore, and let's first add the dependency in the POM file. There's a POM file, we need to add the dependency. Let's paste it there. Go back, and there is the endpoint. We need to configure the endpoint for Actuator as well. Where is it? Production ready features. Yeah, there it is. Endpoints. So these are all of the endpoints that you can configure with your local hosted server so that Actuator works. But there is one which can, there it is, include management.end. This you need to put in your application.properties file. Configuring the endpoints. Let's put star to include all of the endpoints. And since we have added a new dependency, okay, now if we try to load this and type actuator/health, all right, it's working. See, now it's not if some error is being thrown, because sometimes it throws an error. It sometimes works in a very weird way. So what you can do is terminate this and then restart the whole server, and then it will start working. So other than health, also you can see metrics as well. See, you can see every single thing about your website, and all you did is added one dependency. That's it. And you can see you can see and monitor and manage your website's performance and the database and everything else is health just with the help of Actuator. Okay, I believe that was enough. Now moving on to our next question. How does Spring Boot's auto configuration work? We've already talked about auto configuration, but how does it exactly work? Now, auto configuration is like you're booking a hotel, and there is a robot coming out of the hotel. It asks you for what are your preferences, and you say that, okay, I want a hotel room, but other than that, I also need gym access to this. Now, if you have to configure the gym access by yourself, if you have to do it yourself, you'll have to go there, register for the gym, go through all the whatever gym's processes. You have to read through the whole documentation and everything. It's a lot of work. But what this AI does for you is, you would just tell it that I need gym access, and it will be like, okay, done. And you will get your gym pass activated right then and there. And that's how Spring Boot's auto configuration works as well. Spring Boot's auto configuration uses the enable auto configuration annotation to automatically configure your application based on the libraries and dependencies present in the class path. Such as, the moment we added Actuator's dependency in it, it automatically configured the endpoints for us, right? We just added the Spring Boot's starter dependency here in the POM file. We added the dependency, and we allowed because you have to manually allow it as well. So we allowed the endpoints, okay, every endpoint is allowed. And then all you did is you went into the website, you searched for application.health, and then you could see the health of your server right then and there. So this particular endpoint, if you were listen to the part where we were configuring this particular website, we tried to visit this website and nothing was showing. It was showing a white label error, and then we had to manually configure this REST API in order to get this particular website displayed. But here, this actuator.metrics or the actuator.body, or the actuator.health part, we did not configure this website, right? We did not write this code or anything. It was given to you by default. And that is where your Spring Boot's auto configuration comes up. It automatically sets up the websites depending on your preferences. So that is Spring Boot's auto configuration. Moving on, what is the significance of the Spring Boot starter parent in Spring Boot project? This Spring Boot starter parent you can see in, again, pom.xml file. It will be here on top. There, Spring Boot starter parent, and you have a default version here. Now, this I've explained in the beginning as well, that I used to work with JDBC, and it was so difficult because every single year it would have some new properties and new versions coming up, and then I would try to host it and it won't work. It would be like, this version is not compatible, this particular whatever function I'm looking for, it's not present in this version. Or maybe some function was present in that version, in some previous version. Now I'm looking for that function, now it's not there only. They have removed it. They've eliminated, they've terminated that function, they've terminated the whole function. And then it gets very frustrating to go through different documentations, go through the latest Java release documentations, and then you have to read through every single file, find that one version which is compatible with your current version. Spring Boot starter parent directly configures all of this to you. Now, like I said before, it's not the latest version, it's the default version. It brings the default version of everything, so such as the default version of the Actuator, default version of the web starter kit that we installed, that we put in this. Then if I were adding a database, then the default version of that database. So it does all of that for you. So you don't have to worry about version compatibility anymore. Or in technical terms, defines the default versions of common dependencies to ensure compatibility, and highlighting the default versions because it's not the latest version, it's the default version. So it configures the following changes. It sets up the default Java version, which is 17, although it's 22 now, but still 17, the default version. Manages the version of Spring Web applications, configures plugins for building and running the application. Moving on to our next question. How can you define properties in Spring Boot and where are they stored? This is about the application.properties file again. In Spring Boot, properties are configuration values that help you control the application's behavior without messing around with the source code. And these properties are stored in a file that can be accessed by the application at runtime, like the application.properties file. Whenever Spring Boot's application starts running, it always automatically looks for application.properties files, and then whatever properties you have mentioned in it, like for example, I mentioned about the actuators' endpoints, and then I also changed the default server in the beginning. So it checks for it and automatically updates it in the real code, in the main code, and then it runs the file. That's the property defining part. Moving on to our next question. What is the purpose of the REST controller annotation in Spring Boot? Now, the REST controller annotation, it is typically used for building APIs where the client consumes data in a lightweight machine-readable format. What do you mean by the client consumes data in a lightweight machine-readable format? Now, by client, we're not talking about human beings like you and me. We're talking about mobile phones or your tablets or your laptops or your computers with different screen sizes. So what this REST controller does is, you must have seen it here, hello controller. So we set the default endpoint here, right? So I can even add another one. Same. If I copy the code here, paste it here, say I'll call this as greet. I'll put this as greet home. Hello, welcome to this greet. That doesn't make much sense, greet website, but yeah. Now, if I go back here, and if I try to access the greet website here, so you can see that it's changed to greet website. Additionally, the return value of the methods is automatically converted into formats such as JSON or XML, which is suitable for clients to consume without the need for additional view resolution. Now, these REST controllers are also able to return data in form of JSON. Now, if you're accessing that website and if your mobile application is accessing that particular website, then for them, JSON format is much more easier to consume. Like, for example, we took the actuator, right? So here, if we go to actuator/health, you can see that it's returning this in the format of JSON. And this will be way more easier for your web applications to consume, and that's where your REST controller comes into play. Moving on to our next question. How can you create a basic REST API with Spring Boot? Let me just show you that again in case you forgot. So we just created one using greet. Similarly, you can configure other REST API paths as well, and that's how you can create a basic REST API. Creating the REST API is because in every single website, it's very crucial that you must have made that home/about/blog and all in when you're creating HTML pages. You must have done that. So for configuring the same thing in React, you use routes, right? You use React's DOM and router and stuff to configure these pathways. In Java's case, you use REST APIs, and it's very crucial for you to understand how these REST APIs are working. So make sure to practice a lot about this and make sure to completely understand the cases of REST controller, auto configuration, and component scan, and all the other annotation as well, because you can expect a lot of questions from these. Moving on, what is the difference between @component, @service, @repository, and @controller annotations? Let's look at them one by one. The definition can be a bit confusing, but don't get disheartened, because we'll look at an example as well. Towards the end, after you understand the definition, we'll look at an example as well, so that you have a better understanding of what I'm trying to say. Component is basically a generic stereotype annotation used to mark a Java class as a Spring managed bean. Now it's like if you declare any particular class in this particular Eclipse file, you will directly get component class. Now that is to showcase that this particular class is managed by Spring. So that's why you just put component. Next, service is there. Now service is there to handle the logical part of your, if you're putting any logical part in your particular application, that is handled by service, or in technical term, a specialization of head component which indicates that a class contains business logic or service related tasks. Next you have repository. Repository is strictly for databases, a specialization of component that marks a class as the data access object, or the DAO, which interacts with the database. Lastly, we have a controller, which we already looked at, REST controller and everything, which is used in Spring MVC to mark a class as a controller that handles HTTP requests and responses. Now moving on to the example so that you can understand better. Say you have an e-commerce application, 4 parts: component, repository, controller, service. What does these do? Now component is like, say you have to generate random order IDs for your client. So that will be done with component. Next you have to make sure that there should be a module which calculates the total prices of whatever your client is adding into their cart. When they click on purchase, place order button, you need a module in your code which will, whatever they have put in the cart, to summarize the amount of all the objects in their cart, you need a particular module. And for that, you can label that module as @service. Next, repository is there, which obviously saves the product details and the order details. Once the customer places the order, you need to store that order detail somewhere. And to do that, you need to interact with the database as well. For that particular part, you can put @repositories. Next, there is @controller, which processes user actions, such as when the user clicks on a button, add to cart. So suddenly, you need to navigate to another API, that add to cart API. So just the way we did, we configured REST APIs, right? Same thing here also. Whenever the user clicks on something, navigating to that particular page, that is processed by @controller. That is processed by the classes which are labeled as @controllers. Moving on to our next question, how does Spring Boot handle dependency management? Now, in Spring Boot, dependency management is the process of handling external libraries that your application uses. Handling external libraries such as we use the Actuator, we use Spring Web, we can use database as well. Now, the way Spring Boot handles it is called as dependency management. Now, there are a lot of dependencies. Spring Boot Starter Web, Spring Boot Starter Data JPA, Spring Boot Starter Security is there, Spring Boot Starter Actuator is there. Spring Boot Starter Web it includes Spring MVC. Jackson is basically for JSON processing. You saw how it was returning the data type in JSON. That's because of Jackson. And embedded servers, Tomcat. Tomcat is the default one. Again, Jetty and Undertow you'll have to manually configure to handle HTTP requests and for building web applications. Spring Boot Starter JPA is there, which supports the Java Persistent API or JPA to connect and interact with databases using Spring Boot JPA. Security is there for authentication, authorization, and connection and securing your web applications. Starter Actuator is there to monitor the metrics, health checks, and application insights. Moving on to our next question. What is the role of the @value annotation in Spring Boot? Now, we had a hello controller here, right? So first we need to add a value here. Say person.name is Rose. I'll keep that there. And, I don't need to put okay. And now let's come back to our hello controller. And here, I'll try to fetch this value. Okay. @value of person.name, and that will be, let's define the variable for it, private string person name. Let's import this. Okay, now we'll use this, return hello, let's close it there. Now let's add person. Why don't you have autocomplete? Person.name. Okay. Now if we try to run this, Try to run this. Not in greet. Hello Rose, welcome to this website. Now you can see how we defined the value of this person name in the application.properties, and it automatically updated it in the main website. That is the reason why we use value. It is to if you have to like fetch any default value, or if you're going to use any particular variable which is going to keep on changing, like the name, then you can use that value and fetch the value from the application.properties file at compile time. Moving on to our next question, how can you implement exception handling in Spring Boot application? Okay, again, implementation. We can do both custom and global, but custom one will be, let's do the global one instead. Now we need to define one class here. Let's define a class, global exception handler. Okay. Again, now this is a controller, so let me call that advice. Okay. Now this is an exception handler. We're telling Spring Boot that this is going to be an exception handler. Exception dot class. Yes, there. Okay. Now we have the return type will be response entity. We're gonna have some custom error response. We're gonna write down how it's going to respond. Handle exception. Now handle exception takes two parameters. One is the exception, say X, which is basically the exception that happened, and the other one is the web request, which is the particular web command that went wrong. So we'll need to import everything. Import the exception handler, import response entity. This though we'll have to create. Web request also we'll have to put. Okay, everything is imported. Nice. Now we're gonna return response entity dot status. Status by default let's return 500, which is that internal server error. Dot body. Not body. Body. Body is the default return. Whatever you're gonna return, it will be inside. It should be inside the body. Now new, this custom error response, which we still have to write. This something went wrong is very common. No, this is not working. Okay, and request dot get description. This is to protect the if something is wrong. Get description false, we're basically trying to whenever some error happens, you're actually logging that error here with the help of request. But it's up to you if you want to see the entire description of it. Now the problem is sometimes there will be some private credentials which you don't want to expose to just about anyone on the website. So that's why you should always keep the get description as false. Okay, this though we'll have to define. That's it. And what are you? Misplaced what? Misplaced construct. Oh, okay, we're supposed to be here, not there. Thanks for letting me know. Now this we have to create. Alright, so let's just create a custom error response here. New. Inside of this, we're gonna show how we want our return the page to look like. So this is going to be a record. I don't want all of this. Let it stay. Okay. So this is going to be, there's going to be a string message of whatever went wrong. The string details and the status of what went wrong. Status of what went wrong. Okay. Now I believe everything should be working. Okay. So now let's go and check it here. So if I reload this, this is working. So now if I go to some random website, say Kite, it should show this. This is not working. We went to this particular URL, and if we don't have the global exception, then it will show a white label. So instead of that, we have our own custom error. Moving on to our next question, what is the purpose of the configuration annotation in Spring Boot? Now, it is used to mark a class as the source for explicitly defining a bean within a Spring Boot application. That is, if you're going to create a template, or if you're going to create child classes and you're going to follow a particular blueprint. Say if you had to build like a lot of houses and you need to build all of those houses in a similar pattern. So you would need a blueprint which you can refer so that every single house that you're building is matching the first house that you built according to the blueprint. And that is exactly how at configuration also works. If you define a particular template, if you define a class and you add it as at configuration, it acts as a default template which you can use to further create other classes. Next, examples of beans. A bean is like creating a service, or a service as an at database at creating a service as an at service we looked at in the previous questions, or a database connection configuration that can be injected into other components of the application. Okay, moving on to our next question. How does Spring Boot support externalized configuration? What is externalized configuration? Say if you own a car, and when you're driving the same car in a city, there are certain default configurations that your car needs to follow, such as it switches to eco-friendly mode, it adjusts the air conditioning, and it changes the navigation preferences because there will be a lot of traffic in the cities. And now the same car, if it's going in a highway mode, in a highway cruising mode, then again there are a lot of changes that happens. It automatically turns on the cruise mode, it needs to increase the performance setting, the air conditioning and all will change again. Then the traffic will also be changed. There won't be a lot of traffic in if you're going in a rural area. So again, your cars is modes without actually, you're not, if your car was a normal car, you're not changing it into an SUV just because your landscape changed, right? You're changing the preferences of your car to adjust to different scenarios. That is how externalized configuration works in Spring Boot as well. Instead of changing the car's engine for every situation, you just tweak the controls. So similarly, Spring Boot's externalized configuration mechanism allows developers to specify application settings outside of the source code, such as the way I wanted to change the server's port, right? I changed it from 8080 to 8081. That is an external configuration. So that in that application.properties file, you can configure such externalized properties. Moving on to our next question, what are the different ways to package a Spring Boot application? Why, you must have heard of Docker or Kubernetes, right? Sometimes it happens that when you're trying to run a code, or most probably a web application on your computer, it works. And then you show up for Viva in an interview, and you you upload everything on GitHub, and your professor tries to run it, and it's not working. So you'll be like, it's working on my laptop, I don't know why it's not working on yours. So for this, to solve this exact problem, we have packaging. And there are different methods in which we can package a Spring Boot applications. Let's look at them one by one. There is executable jar, executable var, Docker image, and native image. What are these? Say you are shifting from one house to the other, and this new house is like around the neighborhood as well. Plus, you don't even have like a lot of stuff with you. You only have like very basic stuff with you. That is, if you don't have any external dependencies and you only have the bare minimum requirements that you need, in such a case, you don't need a trolley or you don't need like a heavy moving truck or a moving van or anything. All you need is one suitcase. You'll pack everything into that suitcase and you'll move into this new house. Now, this is called as executable jar. We'll look at the technical definitions in the upcoming slides. Next, if you're shifting in this way, but you have a lot of external dependencies as well. A lot of external dependency, as in you have an almirah for storing your clothes. That's an external dependency, right? So if you have all of these stuff, then obviously you cannot pack an almirah in a box. So you need a moving van. And this is the case of executable, var, where you need a moving van to put all of your, where your application has a lot of external dependencies as well, and you need to package all of them in one place. You use executable var. Next, say if you have so many items you need to package your entire house itself. So in that case, you would use a container, although it's not practically possible, but say, let's just assume hypothetically. Then you bring in a crane, which transports this whole container from your one location to the other location. This is called as creating a Docker image, where this is usually used for large scale applications where this issue should not come. Okay, it's working on my PC, why is it not working on yours? This issue should not come. So to resolve this issue, you have containers, Docker image. Lastly, if you have like a very simple application where only the performance matters, it's very simple. So you don't even need a suitcase. All you need is a lightweight backpack to travel from one location to other. And that is known as creating a native image. Or in technical terms, now if we look at them one by one, executable jar is for a self-contained, easy to deploy application that does not need an external web server or that does not even have any external dependencies on it. Next is like your suitcase. Next is your executable war for traditional enterprise environments, which requires now adding a web server like Tomcat or configuring database is obviously an external configuration. So then you need something more bulkier than just a simple jar file, such as your war file or such as your moving van. And you also need helpers, which are your web servers to host it. Next, you have Docker image for a portable containerized solution that can be deployed across cloud platforms. So if you're building a cloud platform, then obviously you need the whole environment setting as well. So for that, you need obviously a container to help you preserve the environment as well. Lastly, we have native image, which is best for performance-sensitive applications requiring fast startups and low memory usage, such as your backpack, which was lightweight and high performance. Moving on to our next question, how can you secure a Spring Boot application? Very simple, use Actuator, use your security starter pack, which you can get in Spring Initializer. But let's understand it from a new perspective. Say if you have a bank applications, there are certain things that you need to make sure of. What things? You need to make sure that the customer should log in with a username and password. They need to have a username and password so that every customer has an individual private page. Only admin users can access sensitive features like approving loans. Communication should be secure using HTTPS. The application must prevent injection attacks to protect the database. What if you're sending every data to the database and some hacker attacks your database using a SQL injection and all of your customers' data is just leaked? That shouldn't happen either. Now your customer should log in with a username and password. That is called as authentication. Only admin users can access sensitive features like approving loan. That is called as authorization. Communication should be secure using HTTPS. That is called as data protection. And the application must prevent injection attacks to protect the database is actually vulnerability patching. So now to apply all of these, you can use different Spring Boot applications, such as for authentication and authorization, you can use that security part. Data protection, you can encrypt your data. There is a bcrypt kind of, I think there's a library called as bcrypt or something. You can use that to hash your passwords and all, so that even if the hacker is able to get their hands on the password, they won't be able to actually use it. So you can use bcrypt and other libraries, other such libraries to keep your password safe. For secure communication, you can use HTTPS and you can use JSON Web Tokens or JWT so that you can manage user sessions, so that it will have a default timer for a user's session, so that as long as the user's session expires, it will automatically log you out, so that after a user has used the session, nobody else will be able to enter into that particular website and manipulate their credentials. Moving on to our next question. What is the role of the @enable configuration annotation in Spring Boot? Say you are a group of friends. Now, if you are planning a particular trip, there are a lot of things that you need to keep in mind of, such as you need to rent a car, you need to find out the whole travel route using Google Maps and everything. Then you need to have your food and snacks prepared as well. Then obviously setting up a playlist is so important because everybody will have different music taste. So you'll have to set up the music taste according to everybody else's preferences as well. Now you have to do this all on your own. Instead, what if you had a little AI bot and you would just tell it, plan a trip? And it will be like, okay, done. And it will set up every single thing, such as it will rent out a car for you. It will find out the exact travel route that you need, what is the fastest route for you. It will find out everything. It will automatically fetch and keep the foods for you. It will set up the playlist according to all of the people you are taking along with, according to their tastes as well. What if you had a little assistant like this, who would do all of this for you? This is basically @enable auto configuration. It streamlines Spring Boot development by automatically setting up configuration based on the application's need. such as it's the backbone of Spring Boot's simplicity which enables developers to focus more on business logic and less on infrastructure, such as if I'm setting up Spring Boot starter web. So obviously Spring Boot will understand that I need Tomcat's server to set up on port 8080 so that I can host my website on this particular default port. That port setting up, and then when I added Actuator, that setting up for the returning the setting up the default return type of the JSON tokens, adding data into it, setting that actuator / metrics ka, setting up that API for me, all of that was done with enable auto configuration. Moving on to our next question, how can you create a RESTful web service using Spring Boot? Okay, this is going to be interesting. Now, hold on. Let's create a web service and let's make things interesting. Instead of accessing it from the local host, it's not kite, from the local host, we'll try to access this API with Postman. So let's first create a class called as, okay, we'll call this book. All right, now in here, we're going to create an API for adding and fetching books. It's going to be our own API, and whenever we call this API, we'll be able to fetch the number of books that we'll be storing in this particular API, and we'll be able to even add more books into this particular API. Keep in mind that the storage will be temporary because we're not configuring a database here. So we'll need an book ID, obviously. Next, we'll need the title of the book, and obviously we'll need the author of the book as well, and we'll just have a default constructor long id string title and the string author. This dot id is equals to id, this dot title is equals to title, this dot author equals to author. All right. Now let's just put the getter and setter methods. Long get id. Can you not do it on your own? No, there's no. We will have to manually type in everything. Return id. Okay, it is there. What is there? Create getter and setter. Yes. Oh, thank God, at least one default thing is there in this. Author, create getter setter. Same as for id, create getter setter. Okay. And we have the getters and setter method as well. Now we need another class called as, let's see this, it's called as book controller for generating the REST API. Where is new? Oh. This will be your book controller. All right, obviously it's going to be a REST controller and a request mapping of books. Okay. We'll need to import both of these. Let's create a list for our books. Books is equals to new array list. I'll have to import util class. Okay. Now we need to add a get mapping. Public list book get all books. Okay, this is going to have return type as, it's going to return books. Next, let's add a post mapping, as in what happens when we make a post request. We have done a get request. Now let's do a post. Okay, I haven't tried to wrote the body yet. Public book. Add body will be, no, add book will be the name. Request body will be book. Okay. Now what we're gonna do is in this particular list we will add whatever the new book the user has given in the post request. Then we're just gonna return it book. Okay, we'll have to import all of these things and post mapping as well. Now okay, now let's just take this. Okay, now let's go to books. Also it should be, there should be nothing. Yeah, it should not be working. So let's open Postman. Let me put my URL here. Now if I put a GET request, okay, this is not working. Something went wrong. What did we do wrong? Oh, I didn't save it. Okay, let me send that again. Yes, now it's working. I didn't save it, that's why. Okay, now let's make a post request. But to make a post request, we need to send some body as well. So let's say I'm looking for before the coffee gets cold. It's an amazing book. Okay, so let's take that. The ID, let's keep it as 1. Yes, and the title is Before the Coffee Gets Cold. And lastly, we have the author. I don't know the name of the author, I forgot. I'm not going to pronounce that. I know it will not be correct. So, okay, there we go. What is, okay, that's it. Now let's make a post request to this. Let's send it there. And it's gone. Okay, now if we try to make a GET request, you will see that this ID is being returned to us. Similarly, if I go into our website as well, and even if I try to do it here, you can see that we can see the particular book that we just included, but because we have not included a database in this, it will be temporary, meaning if you restart your server, this will be gone. So that's it for this question. Let's move on to our next question. Okay, what is the significance of the @entity annotation in Spring Boot? So when you look at the movie posters, you see a bunch of details about the movie, such as the title of the movie, the rating of the movie, the director, the duration, the language. You see a lot of meta information about the movie without actually knowing about the movie itself, right? Similarly, @entity is an entity class isn't the data itself, but it defines how it's being represented in the database, such as the name of the rows, the columns, and everything. Or in technical term, it generates a SQL statements to create, read, update, and delete rows in the corresponding database table, and it maps the classes, fields, attributes to the columns of the database table. You must have used MongoDB. In that also you create entities. Same thing here as well. Moving on to our next question. What are some common testing annotations used in Spring Boot? Now in Spring Boot there are a lot of testing annotation used. Let's look at some of the common ones. There is Spring Boot test, AutoWide, Mockbean, Data JPA test. Let's look at all of them with the help of examples so that you have a better understanding. Spring Boot test is used for an integration testing. It runs the application with its real configurations, making it suitable for testing interaction between components. Say you have different components, like I have hello component is there, hello greet component is there. So I have a bunch of components right now in Eclipse as well. So just to check that everything is working fine as expected, you have Spring Boot test. If you have a restaurant and you want to see if everything is working fine, you will bring customers in there. Customers will place orders. There'll be a chef who processes these orders. There'll be a waiter who will be coming to take the orders from the people and going to the chef, telling him to cook the food. The chef will cook the food, give it to the waiter. The waiter will go back, give it to the customers. So you haven't actually opened your restaurant, but you're checking the full restaurant at once to see that everything is working as you have expected it to. Next, we have test. Test marks a method as a test method. It tells JUnit that the method should be executed as a unit test. In this particular case, you're not testing the whole application at once. Instead, you check only a particular part of the application. Such as, say, coming back to our example, your customers are there, your waiter is there, your waiter give the food. Now you hand over a sample bill to your waiter just to see if your waiter is able to remember all the food items that the customers ordered. And if the waiter is correctly able to calculate the bill, then only you will keep the waiter in your restaurant, right? If it's some person who can't do that, then obviously you won't keep them there. So testing the individual components is called as your test. At test. Next, you have auto-wired. Auto-wired is used for dependency injections. Automatically inject beans into the test class so that component services or repositories can be tested directly. For example, if you have to hire a waiter, or if you need a chef, or if you need an assistant who will assist the chef, or if you need even an actor who will be just going around entertaining the people. For all of this, instead of you going out and hiring the people yourself, you can keep a manager there perhaps, who will interview these people and hire them for you on their own. That is how auto-wired works. Moving on, we have mockbean. Now mockbean is create mockbean in Spring Boot tests used to mock services. Because sometimes it happens when you have to test an application, test a database configuration. Maybe there's some error in the database's code, but the connection that you have made to the database, if you just want to check if the connection is correct or not, you can use mockbean. Such as if you have a chef in the kitchen who's, say, your database, who actually cooks food, instead of bringing the chef, you bring an actor who is pretending to be a chef. So he'll pretend to cook, although he's not actually cooking, but he is cooking. So that when you look from afar, the kitchen is working as it's supposed to be, although the chef is not actually cooking, but yeah, it's there. And the last one, we have data JPA test, which is used for testing JPA repositories. JPA repository is your Java persistent API, again your database connection. It focuses on repository testing for faster database connections. Moving on to the next question, what is the purpose of the application.yml file in Spring Boot? So let's look at what are the benefits of using application.yml instead of application.properties. It provides a centralized configuration, meaning it serves as a single place to manage configuration properties for the application, like we've already discussed. Then there is environment-specific profiles. You can define settings for different environments, such as the development environment, testing environment, production environment, using different profiles. Next, there is readability, meaning the YAML syntax is much more cleaner and much more structured as compared to application properties' default format. Next, there is a hierarchical structure. It supports nested configuration, making it easier to organize related tasks. Say, if you had this code, okay, let's just use ChatGPT to do that. Convert this application.properties file into YAML file. Okay. So look at how there's a hierarchical structure. Spring application name, management endpoint web exposure include this. Person's name is Rose. That is what we're talking about when we are referring to this hierarchical structure. Then there is dynamic configuration, meaning Spring Boot reads the file at startup and applies the configurations to the application. So whenever the application is starting to run, whenever the application compiles, all of the default setting, the application.yml file is read first, and then all of the default externalized configuration that you have applied in the application.yml file is automatically mapped into the main file. So moving on to our last question, how can you monitor and manage a Spring Boot application in production? Now, Spring Boot provides built-in tools and integrations to monitor and manage applications during your production. One such great example is your Spring Boot Actuator that you already used. Additionally, you can integrate monitoring tools such as Prometheus. That is another monitoring tool which you can use, and that also provides like a visualized table so that you can see instead of getting the result in a JSON format, you can see it in a visualized way, much like your car's dashboard. Then there is application management as well. And with that, we reach the end of this video. Thank you so much for tuning in, and I'll see you guys next time.